Hi ladies, this is lesson 7.4 and this is part 2. In this part we're going to look at the graphing portion of logarithmic functions. So remember that logarithmic functions are inverses of exponential functions. So if you look at this key concept that's on your note sheet, the graph of log with base b of x, where b is greater than 1, and where b is between 0 and 1 are shown on this diagram. So here is where b, here's the exponential function, where b is greater than 1, it's an exponential growth. Since the logarithmic function is an inverse of that, it's the reflection over the line y equals x. So not over the x-axis, like if we had a negative a value, but over y equals x. So here is the logarithmic function. Now in the second graph, this is the function. This would be a decay function. That's where b is less than 1 but greater than 0. And here is its reflected line. This would be the logarithmic function. So we're going to look at graphing those in this video. So when we're graphing logarithmic functions, a couple things that you should note is that you want to pick points that are convenient to plot. And then secondly, you want to pay attention to where your asymptote is. So if you remember in exponential functions, so in a function like y equals a times b to the x power, our asymptote was horizontal. But here we're working with an inverse function of an exponential function. So here we're looking for a function y equals the log of base b, log with base b of x. And so our asymptote is vertical. Okay, so that means when we shift left or right, our asymptote changes. Here, shifting in the first one, shifting up or down would change our asymptote. But here, in this logarithmic function, a shift left or right changes our asymptote. Okay, so let's look at this function y equals log of base 2 of x. So here we want to choose a few convenient points. In our exponential functions, we always chose 0 and 1. And so in this function, we're going to choose 0 as the exponent and 1 as the exponent, and we'll pick a second exponent just so until we get familiar with these. So choose convenient points. So if you rewrite this as an exponential function, you would say 2 to the y power equals x. So when we choose x coordinates, we're going to choose when x is 1. We're going to choose when x is b to the first power, so whatever our base is to the first power. And we're going to choose b to the second power. Okay, so let's look at what a few of those points would be. So the first one, we're going to choose 1. So 2 to the what power equals 1. 2 to the 0 power equals 1. We're going to choose our base, which is b, 2. And we're going to look 2 to the what power is equal to 2. 2 to the first power is 2. And then we'll choose our base squared, which is 4. So 2 to the what power is equal to 4. 2 to the second power is equal to 4. Okay, and then we'll graph those points. And again, since now we're looking at logarithmic functions, our asymptote is a vertical line. So our asymptote is that y-axis instead of the x-axis like we did with exponential functions. So we're going to plot those points 1, 0, 2, 1, and 4, 2. And then we're going to sketch in our graph. All right, now let's look at the second one because this one's a little bit different because the base is between 0 and 1. So we're still going to choose convenient points. But here our convenient points are a little bit different. Still, we're going to choose 1 or 1 over b because it's a fraction. And then we're going to choose also 1 over b squared. Okay, so let's look at what those points are in this particular graph. We're going to choose 1. So again, if we rewrite this as an exponential function, it would be 1/3 to the y power, 1/3 to the x power, no, 1/3 to the y power, here we go, equals x. All right, 1/3 to the y power equals x, that's the exponential form of this logarithmic function. So 1/3 to the what power equals 1. 1/3 to the 0 power equals 1. And then we're going to choose 1 over b. So here's our b, 1/3. 1 divided by 1/3 is 3. And we're also going to choose 1 over b squared. So 1 over 3 squared, 1 over 1/9 is 9. So you want to just steer away from choosing numbers that are too small, that end up being too close together because it won't give you an accurate graph. Okay, so if our x value is 3, we're looking for 1/3 to the what power gives us 3. And in this case, it's -1. And in the last one, we're looking for 1/3 to the what power equals 9, and that's -2. So now let's plot those points. So we have 1, 0, 3, -1, and 9, -2. Now in this case, again, since it's a logarithmic function, our asymptote is the y-axis. So you should sketch in your asymptote just so you know not to go past that. And then you can sketch in your actual graph. Okay, so now looking at this section right here, y equals log base b times x minus h plus k. We're going to do this just like we did logarithmic function or exponential functions. We're going to graph the function first, and then we're going to translate it. So we're not going to worry about those h and k values initially, but when we do see those h values, we know that we're going to translate this graph, y equals the log with base b of x, h units horizontally and k units vertically. And again, since now our asymptote is a vertical line, when we move horizontally, that's going to change our asymptote. So with logarithmic functions, we always said that our domain was all real numbers and our range was restricted by our asymptote. But in logarithmic functions, our domain is restricted. So looking at this first graph, our domain is x is greater than 0, and our range is all real numbers. Same is true with the second graph. Our domain is restricted by our asymptote. So our domain is x is greater than 0, and our range is all real numbers. So as our graph shifts horizontally to the left or the right, that's when our domain is going to change. Our range, since it's already all real numbers, is not going to change by a vertical shift. So let's try this one where we have to translate the graph, where we translate a logarithmic function. So first, again, you want to keep in mind that our function is stated as log with base b of x minus h plus k. So first, we're going to graph just this first part. Okay, so let's choose a few convenient points here. So again, we're always going to choose 1. We're going to choose the base, and the base squared is always a good one to pick as well. And then our y values are 0, 1, and 2. So 3 to the 0 power is equal to 1. 3 to the first power is equal to 3, and 3 to the second power is equal to 9. Okay, so first we're going to plot those points. 1, 0, 3, 1, and 9, 2. We're going to sketch in our graph. Again, our asymptote here is the vertical line of the y-axis. And then our second step is to translate the graph. So we're going to translate h units horizontally and k units vertically. So first we want to identify our h value and our k value. So here our h value is 1 and our k value is 2. So we want to draw in our new asymptote first. That's the first thing that we should do so that we don't accidentally cross that axis or that asymptote when we sketch in our graph. Since we're moving it h units to the right, 1 unit to the right, our asymptote changes to the right 1 unit. So now our asymptote is the x equals 1 line. And now we can shift our points. So I'm going to move this point 1 unit to the right and 2 units up. I'm going to move this point 1 unit to the right and 2 units up. And then again, 1 unit to the right, 2 units up. And I'm going to sketch in that new graph, not crossing my asymptote. Now let's define the domain and range here. Again, because it's an inverse of an exponential function, our domain is now restricted by our asymptote, and our range is all real numbers. So looking at our graph, that green graph, that only covers values where x is greater than 1 because our horizontal asymptote is that x equals 1 line. All right, try this next one on your own. Again, you're going to just start by graphing this function. And just to keep in your mind here, we're looking at log of base b, x minus h plus k. So if you were to rewrite this just with your h and your k values in, it would be log with base 1/2 to the x minus 0 plus k. So pause the video while you work, and then you can unpause for the solution. All right, so again, you're going to want to choose a few convenient points. So we're going to choose when x is 1, when x is 2, and when x is 4. And then you can evaluate your y, 0, -1, and -2. Then plot those points. And then you have a translation here. Now your h value is 0. So that means that your asymptote does not change. You still have that vertical asymptote of x equals 0. And you can see that by that dotted green line on the graph. That's my asymptote. But we do have to translate the graph 3 units down because our k value is -3. This is our k value right here. So now defining the domain and range. Again, our domain is now set by our asymptote. So our domain is x is greater than 0, and our range is y is all real numbers. So please jot down any questions you have, and we can go over them in class when I see you. Thanks.